explore that bit.ly link which I gave you in the last class? Do you remember I shared a sheet with you, bit.ly/Khushi ma'am? Anybody? No? Okay, no issues. But make sure that this time you will, explore that sheet, because it it contains the everything, whether it's notes, DPP, lecture recording, or anything else. Okay, so it is a well-maintained sheet for you. I hope it will help you, right? See, you need to respond,
Yes.
to make the class interactive. Yeah. Okay. You have the mic access. Kindly use it. Okay. It's your class. I want you to make the sounds. I mean, not the noise, but at least raise the query and ask me the questions and everything. Just make the conversation. That's the point. Okay. So without further delay, let's start the class. This is second lecture of units and dimension, and today we will talk about vernier calipers screw gauge, but we will discuss it later on. But for time being, the most important thing which I want to discuss with you is significant figure and that rounding off. And then the most important topic of this entire chapter for us, which is error. Okay. So first we discuss significant figure, rounding off, then we will go with error, and in the end, we will discuss these instruments. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Cool. So, wait a minute. I think somebody wants to, yeah, take it. So, as I already discussed, that the weightage of this chapter is 8% in your NEET exam. So, it is very important. Plus, I told you that the concept and this question to concept ratio is much, much higher. Okay. So, we need to focus on this chapter. Okay. Can you tell me what we have done in the last class? If you remember.
Fundamental quantities, derived quantities.
Supplementary quantities.
Fundamental. Then we discussed about the derived quantities, and then we talked about the supplementary ones. Okay, can anybody
Dimensional
explain what
analysis.
are?
Dimensional analysis.
Very nice.
Principle of homogeneity.
Very good. So let's start. I hope this spelling is correct. Otherwise, please check it out. So, can anyone explain me what do we mean by supplementary quantities? Haji, yes, Shikha, please.
Ma'am, those quantities which are dimensionless but have units.
Can you give me the examples?
Ma'am, angle and solid angle.
Very nice. Okay. Can someone else tell me about the principle of homogeneity? Should I call out the name? Rupali Shahu. Can you explain, bacha? हाँ kiddo? Rupali? See, if you don't want to answer, you can just say कि ma'am pass. कि I'll pass this question to somebody else. Okay, Mishba. Come on, that's cool. Batao, Mishba.
Dimension of each of the terms of a dimensional equation on both sides should be the same.
Okay. Harshida, you want to add something?
The dimensions of any physical quantity should be same in the addition or subtraction.
Very nice. Anybody wants to add anything in these two explanations? Gayatri, do you want to contribute? Bolo.
Ma'am, the dimension of all atoms' physical expression should be same.
Okay, that's cool. That's cool. The basic thing is principle of homogeneity. Just explain a very basic rule which we already know. But here we have a sentence that you cannot add 2 meter into 2 seconds. That is nonsense. Okay. You can add or subtract only those quantities who have this which have the same dimension basically or same units, but I can multiply or divide with different quantities. That would work for me. For an example, 2 meter by 2 second, that gives me 1 meter per second, which is okay, but 2 meter plus 2 second is nothing, right? And yeah, so let's come to a question first. Okay, these are the uses of dimensional analysis which I taught you in the last class. There are physical quantity. Okay, a physical quantity can convert it from one system to the another system. This is the first use. The second one, you can check the dimensional correctness of a given relation. And the third one, you can establish the relation between different physical quantities, right? So this is something that I have already discussed with you. Can you tell me this one? Although it's a homework question for you, if you remember. I gave you this question and Harshada, yes.
Ma'am, here first we can say that T is directly proportional to mass, and T is directly proportional to L, and T is also directly proportional to gravity. And we can add the powers like X, Y, and Z. In all together, we can say that T is directly proportional to M raised to X, L raised to Y, G raised to Z. Therefore, T is equals to K constant, M raised to X, L raised to Y, and GZ to Z. Then we have to make the dimensions equal. Likewise, we know in the left hand side the dimension of T is T1 is equals to K. Dimension of M is M raised to X. Dimension of L is L raised to Y. And dimension of G is LT raised to minus 2 raised to the power Z. In all together, we have added that T raised to the power 1 is equals to K in whole bracket M raised to the power X, L raised to the power Y plus Z, T raised to the power minus 2Z. So that now we can
Okay,
find the
Harsha.
values.
Okay. Sorry to cut you in between. Can you tell me the last expression, the result, whatever you are getting?
Yes, ma'am.
Yes.
T raised to 1,
T.
T raised to 1
Hmm.
is equals to K
Hmm.
whole bracket
Hmm.
M raised to X,
Hmm.
L raised to Y plus Z,
And
T raised to minus 2Z.
okay. Okay. See, okay, that's cool. A nice expression, and actually you started very well. But the thing is, question is asking about the time period T. They are asking about an expression. Like in previous question, which I discussed with you in the class, we got the expression as F is equals to MA. And even for me, for time being, K would be okay. F is equals to KMA. Experimentally, I know that K would be 1 and the expression finally come as F is equals to MA. That would work for me. But when somebody is asked about the expression, so you need to find out the expression first, Bacha.
Ma'am, I have got the expression.
What it would be?
Ma'am, after solving the values of X, it is X value is 0, Z it is minus 1 by 2, and Y is plus 1 by 2. Then I have put it to the powers like T is equals to K, M that means X raised to the power 0, so M raised to 0, L raised to 1 by 2 and G raised to minus 1 by 2. And it means that power half, that means they are in under root. So the formula is T is equals to K constant under root L upon G. That is K constant is 2 pi for the time period. So the formula is T is equals to 2 pi under root L upon G.
Yes, very good. Yes, it is the correct one. Is it okay from everyone's end? I guess you all try this. Anna, have you tried it? Okay, cool.
Excuse me, ma'am.
Yes, yes, yes.
Ma'am, I have a small doubt in the dimension of that alpha and beta question.
Can you tell me the expression, Vita?
Yes, ma'am.
Which one?
P is equals to alpha into E raised to minus beta upon Z. Z
Okay.
is denoted as temperature
Okay.
and
And
P for
P is
pressure.
pressure, right?
Yes.
Okay.
Ma'am,
So I
here,
ask you about the find the dimension of alpha and beta, or there is some
yes, ma'am.
relation? Acha, okay.
Ma'am,
Alpha and beta. Okay.
according to my convention, I have tried that dimension of beta. That means it is dimensionless because any number, it is the power of E. So any number raised to its power has dimensionless.
Okay.
Is
Wait
it
a
right?
second. See, e raised to the power something. Whenever you have to deal with the exponent or the power, you have to be very clear about it. It is dimensionless. Because we have never seen or we have never heard about it, 2 raised to the power 3 meter per second. We have never see this kind of expression. Now, the exponents are supposed to be dimensionless, unitless. So this beta by z has to be dimensionless. And I told you, so you can write beta by z has to be dimensionless. Dimensionless. Okay. Since this is temperature, in order to make this entire expression dimensionless, you get the idea that beta is temperature inverse. It means theta inverse, right? This is a dimension of beta. When it comes to alpha, see, if I am using this equal sign, then it is possible only in that situation when left hand side and right hand side holds the same dimension. So alpha has the same dimension as P holds. So dimension of P. And it means force by area. Right?
Yes, ma'am. I have got of alpha, but I couldn't find out beta.
Okay. Okay, so you got the idea, na? Beta, for
Yes,
every
ma'am.
time when you have to deal with the powers, make sure that that power is supposed to be dimensionless. Is it okay to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, kindly, okay, give me a thumbs up if some, okay, Namrata, Shikha, Harshda, Anushka, cool. Anusha, that's cool, everybody is giving me the, okay, Gayatri, Mantusha, nice. Okay, let's move on to the next concept, and that is significant figures. So before reading this out, can you tell me what are significant figures? Yeah, tell me. I gave you pre-work, you have to study, you have to read at least about significant figures and rounding off. Can you tell me what are significant figures?
All the non-zero digits.
Okay, Namrata is a new one. हाँ Namrata, please आप बताइए.
The reliable digit plus the first uncertain digit are known as significant figures.
Okay. Anybody else? Just raise the hand and ask. Okay, Anusha. That's cool. Anusha बताइए.
The significant figures are the numbers of digits up to which we are sure about their accuracy.
Very nice. Very good. Shikha, do you want to add something, bacha?
No, ma'am, I had to say the same thing.
Okay, that's cool. Okay. So you all are correct, basically. Significant figures are the figures or the number of digits in a number in a given value, which we are confident about. I'm okay. This much is okay. This much is fine. This much is correct. So that confidence wala equation, na, that confidence wala digit is the number of significant figures. For an example, I gave you an expression like 4038. Just remove 0 for some reason over here. Let's say 4138. Can you tell me the number of significant figures in this given number?
4.
4. Right? 1, 2, 3, 4. Now just go through the definition also. The significant figures of a given number, let me change the ink, are those significant or important digits. Just forget about this word, only focus here. Significant, which convey the meaning according to its accuracy. I am not kidding. This is the question which is asked in your exam. I just forget the year. They ask you how significant figures and accuracy are connected to each other. So you will always remember, the more significant figures you have in a data, the more it will be, the more it is accurate. Okay, this is directly proportional. Accuracy and significant figures ka number. Cool. Number of significant figures is directly proportional to the accuracy of the data. Is that fine? Okay. Let's come to the rules of significant figures. Number 1 is all non-zero digits are significant. As I just gave the example. So for an example, you have this number also. It contains 6 significant figures, right? Non-zero digits will be considered as the significant figure. When it comes to second rule, okay, whenever you find something fishy, just ask me, ma'am, this is something I'm not clear about. Okay, I'll explain that. Now come to the second rule. It says all zeros that occur between any two non-zero digits. Okay, just wait a minute. In these significant figures, you will have 3 kind of zeros, basically. You have leading zeros. You will have trapped zeros. And the last category is trailing zeros. So as their name suggests, their position also. Like leading one is like this. Okay, this. Trapped, yani ki, when a zero is trapped in between two non-zero digits. For an example, 1003. Trailing zeros, the one that are in the end. Okay, ending zeros. For example, 100, like this. Okay, so on the basis of position, you have 3 kind of zeros over here. Now study these points. You will understand it better now. So they said ki occur between any two. It means trapped zeros. Whenever you have trapped zero, they will act as significant figure. For example, in this digit, tell me the number of significant figures. And I am assuming you are not reading the entire line.
7. 7.
Yeah. See, 1, 2, 3, 4, 5, 6, 7. Right? 7 significant figures. Are you getting my point? Whenever you have a trapped zero, trapped means that zero is trapped in between two non-zero digits. You will always count those zeros as significant figures. How many significant figures do we have here?
4. 4.
Cool. Okay, let's come to the third rule. All zeros that are on the right of a decimal point, and also to the left of a non-zero digit is never significant. Okay. So as simple as that, here. Tell me the number of significant figures.
3. 3.
3.
Cool. Here. Now you may ask the doubt. Do you have any doubt over here? Why I have counted these zeros, not this one? See. Okay, let me tell you the reason behind it. I gave you 2 scales. Okay? One is scale number A and the other one would be scale B. Scale A is only efficient to find the values around like 20, like 1 decimal place only. Okay? this B scale can give me the answers on 2 decimal places. You have two decimal places. Which one is more accurate?
B skill.
B.
Very good. Yes, because you can answer me over here. For example, I gave you an object to measure the length of it, and I said, "Ki just give me the data." I know the actual length of this object is, let's say, any number 7.85. For an example, some centimeters. This is the dimension. Oh, sorry, the length of this object. So so you can measure only 7.8 from this scale, but the entire value can be given by this, because if you have the scale which can measure only up to 1 decimal place, and if I gave you an object which has value like something like this, so what would this scale would do? It would say either 7.8 or 7.9. There is nothing in between. But this scale can give you the spectrum. Is that okay? So that's what these zeros are actually representing. Whatever device you have, it can calculate over 2 decimal places. You have 2 decimal places. That's the point. Let's come to the second last point, and it says all zeros that are on the right of the last non-zero. Okay. Here you will count these zeros also, since they are coming after the decimal value. Decimal point.
Decimal
So you
point.
have to consider these significant results. Okay. And then last we have all the zeros that are on the right of the last non-zero are significant if they come from a measurement. This is a very nice thing actually. Now let me explain this last point. If I gave you a number 20, and then in another instance, I give you the example 20 meter. How many significant figures do we have here?
2.
2.
Are you sure? I just
Yes,
tell you,
ma'am.
whenever
Yes,
you
ma'am.
have trailing zero, you will not count them if they are not coming after decimal place. So there is no decimal place now. You will answer me 20. Oh, sorry, 1. Right? If I ask you 20.00, then only now you will answer me. Ma'am, number of significant figures are 4. But there is no decimal place, no decimal point. So it would be 1. If I put a it over here, it means I give you a sense कि भाई I stored this digit. Why am any measurement? I do a measurement and then I'm giving you the answer. So in this case, you will answer me 2 significant figures. Now just go through this last point and let me know if you find it difficult. Okay, there are 2 more points. Whenever you have some expression like 10 raised to the power minus 3 or plus 3 or anything, so this is known as the order. Okay, and order has no significance. Okay, order has no significant figure. If I gave you a pure number, for example, I said ki bhai, you have the parameter of the square, and that is 4 times of side, right? I'll ask you about this number. Can you tell me how many number of significant figures do we have over here? She would answer me, ma'am, infinite significant figures. Okay, so pure numbers has infinite significant figures. Is that okay?
Yes, ma'am. Yes, ma'am.
So you have 1, 2, 3, 4, 5, 6. This is the 7th rule, and this is the 8th rule. Is it okay?
Okay, ma'am.
Okay. Let's try these rules. Let's practice. You have 4 digits over here. I'll give you 2 minutes. ठीक है, and then I'll ask you about the answers. उससे पहले you just have to raise your hand and then let me know कि मैम हमारा हो गया. So it is 18:16 right now. Take 2 minutes and give me the answers after it. Okay, time is up. Aditya, can you tell me?
Ma'am, first one has two significant figures.
Okay.
Second one, three.
Second. Very nice.
Third one
Third
has three,
one.
ma'am. Three,
And the fourth one?
one.
Okay. Okay. Shikha, is it okay? Or do you want to change anything?
Ma'am, the fourth one would be 3.
Okay. So Shikha said कि it is supposed to be 3, right? Do you want to change something or is it fine?
It's fine, ma'am. 3 is the right option for 4.
Okay. Anusha, Harshda, and Misbah. Are you all okay with the answers?
Yes, ma'am. All are correct.
Okay. Okay, that's okay. Aditya, very nice, bacha. You are absolutely correct. It is 2, it is 3, it is 3. But see, it is 3 also. Why? Because it is 2.00. I told you whenever you have a decimal point, after that you will count all the zeros. Okay?
Okay, ma'am.
But only make sure that they are not leading zeros. I mean, if
Okay, ma'am.
I wrote it 2.03 and let's say here I have 0, in that case, only one significant figure would be there. But if I write 0, 0 here also, now you can tell me, now you can give me the answer, ma'am, here I have 3 significant figures.
Three.
Is it okay?
Yes, ma'am.
Okay. That's cool. I hope it is enough for significant figures. Now let's come to this rounding off. Okay, so rounding off is something which we use in our daily life also. For example, if somebody gave you 100 rupees, and you use 90 rupees, you spend it somewhere. But still, when your mom tell this thing to your dad, she would say he spent the entire 100 rupees. They will not count the remaining amount. Okay, so you have to listen all the music, why are you spending so much money, whatever the thing is. But it's approximation which we use in our daily life. So that is what we are doing, but scientifically over here. So in rounding off, we have the very simple thing. We'll just go by the rules only. Okay? It's very easy actually to understand. So let's start with, okay, just give me a minute. My screen is stuck. Just, yeah. Okay, so rule number 1. If the digit to be rounded off is more than 5, then the preceding digit is increased by 1. It means if I have this number over here, let's say 4.67, okay? And I said, please round it off up to 2 significant figures. So what would you do? You will say, I have to round off this number now, so that I will get some number which have 2 significant figures only. So you have to check whatever
4.7.
number you are. Yeah. So you have to check whatever the digit you have to round off. The preceding one is greater than 5 or the smaller than 5. If it is greater than 5, so you will increase it by 1. You will answer me 4.7. Okay. If the preceding digit is in yeah, if it is more than 5, then preceding digit is increased by 1. This 7 is more than 5, then you have to add 1 over here. If I wrote 4.63, then, and again I want to
4.6.
4.66.
4.63.
It is left unchanged. Okay. Now, what if it is equals to 1? Sorry, it is equals to 5. अभी
4.6.
क्या? Okay. Is there any rule?
Yes, ma'am.
What? See, you have to check whatever the number you have, right? Whatever the digit you. If let's say here we have 2 more places. Here you can have odd, you can have even number, you can have 0, right? Only these 3 things can be now. Anyone?
Yes, ma'am.
In that
Yes,
situation,
ma'am.
there is a few rules which we need to follow. Okay. So if you want to study this entire page, then please go through that, and I will give you the briefing about this one. Okay. So just go through these 2 rules and let me know, and then we will discuss this 5 wala. Om and Anusha, do you want to ask something? Because your hands are, raised. Okay. Okay. Take care. Cool. Do we have a space? We will solve these questions later on. Just focus on what I'm explaining to you. Okay? Let's say we have 0 over here. Okay? If I have 0 in the, after this 5, so I have to see this value. I have to check what is the digit preceding the 5. 5 ke pehle kya hai? It either odd or even. So I will make a table over here. Let's say it is odd, then I have 5, and then I have 0. And the second scenario would be, here I have even number, then 5, and then 0. Okay, there are 2 possibilities in this situation. So if you have odd and then 5, okay, if you have odd and then 5, in that situation, add the 1. And if you have even and then 5, in this situation, there is no need to change anything. Is that okay?
Yes, ma'am.
Yes, ma'am.
For example, I have 2.750. Now, after 5, you have 0. So you need to check this value. Okay? Before 5, what you have. So in this situation, I have odd number. So whenever I will answer about this approximation or this rounding off, I will give 2.8. Okay? You will add +1 in this odd number. You will make no change in this even number. For an example, you have 2.650. In this case, the rounding off would be like this, 2.6. Is it okay?
Yes, ma'am.
Paka? Cool. Now, second scenario. What if I have odd or even over here, right? So they said in this situation, you can have two scenarios again, either 5 and odd, or you have this case, 5 or even, right? If you have this case, then please make no change. And if you have this, add 1. Is that okay? For an example, you have, let's say, 4.753. So after 5, you have an odd number. In this situation, the answer would be 4.7. Here, let's say you have something, where should I write? Here. Okay, let's say 4.856. In this situation, you will give me the answer as 9. Is that okay? If you have any doubt, please raise your hand and we will discuss it regarding this approximation. Yes, please.
Ma'am, you told just now that after 5, if there is a even number, then we do not have to change it, and if there is an odd number, we have to change it, no?
No. You have two scenarios. If you have 0 after 5, in that situation, the dealing is different. But when you have odd or even number, in that situation, you have to do whatever I've wrote here in blue. Okay? That is something you need to follow. These are two different things.
Okay, ma'am.
Okay. So now you have 4 questions and you have to round off them up to 2 results. Kindly do it and answer me within 2 minutes. Again, you have to raise your hand and ask to everyone. Okay? It is 18:29 right now. Answer me about 18:31. Okay, so time is up. Mantusha, can you start, bacha?
Yes, ma'am.
Yes.
First one, 4.4.
Okay.
Second one, 4.4.
Cool.
Third one, 4.4.
Nice.
Last one, 4.8.
Good. Is everyone okay with this answer, or there is some change you want to do? Is
Ma'am,
there
third
any
one
Third
is
deviation?
one is
No,
The third
third one is
4.4.
4.4.
4.4.
Third one is 4.4.
Okay. And fourth?
fourth
Acha,
is
yeah,
correct, ma'am.
she also, I think she also tell me the 4.4, na? Yes. So it's okay. I guess the tricky part is only how to deal this five wala thing. Otherwise, this is something which we already know, right? Yes. Let's come to the calculation of significant figures. We have four fundamental, operations, mathematical operations: addition, subtraction, multiplication, division. So we will deal with that. In addition and subtraction, you will always remember that the result of these operations is rounded off to the same number of decimal places. Please pay attention to this line. Same number of decimal places as present in the value with least decimal places. Decimal places. For example, let's say I gave you a number 4.83 plus 4.9. So whatever you will answer, Meena, you have to go only up to one decimal place. Because here you have two decimal places, here you have one. So you will consider the least value with the least decimal places, okay? So first, just perform the basic mathematical addition. For example, in this case, it would be 3 and 17, 1, 8, 199. Write this. Now you have to round off it to up to one decimal place. So here is 3.
Nine.
Yani ki it would be 9.7. Right? Okay? Okay. Now let's come to this multiplication and division. Here, the result is rounded off to the same number of significant figures. Here you have to deal with the significant figures as present in the value with least number of significant figures. For example, I gave you, let's say, two numbers, 20.0 multiplied by 2.01. So first perform the basic multiplication. Like in this case, it would be 402, okay? And like this. Now calculate the number of significant figures in the given digits. Like here I have 3 significant figures, and here I will also have 3. Okay, we need to change it somehow. Let's say this. So here we have 4 significant figures, and here we have 3 significant figures. So you have to leave the answer with 3 significant figures only. Is that okay? Okay. This is something which you will do in your homework, and we will discuss it in the next class if you find it difficult to solve. Okay? Let's come to the, okay, we have 10 minutes, we can cover this topic. Error. Error is something that is a human tendency also. It could be on a lot of unknown factors also. And sometimes it can be measurable parameter also for us, right? So they defined error as, wait a minute. The difference between the measured and the actual value. Okay? Difference between measured, or you can also get the true value. Okay? Measured or true value minus the sorry. Measured value and find out the difference of it from true or actual value, right? This is the error. It could be of many types, and we have to study those types. Is it okay? Kindly give me a thumbs up
Yes,
if
ma'am.
it's fine. Okay. So here we have few types to calculate this, error. For example, I give you something to measure and you give me the data. Like I give you rod, please measure the length of this rod, and you give me, let's say, 10 readings. Okay. So data may be like this: x1, x2, x3 up to, let's say, xn. Okay. These are the readings. So first I need to calculate the true value. True value is average of this entire data, right? The sum of all the observations upon number of observations. Okay? You can say this x mean as the true value. Once you got this, let's calculate the absolute error, because absolute error is nothing but the difference between true value and the reading. Okay? The deviation of your reading from this mean value. This is the absolute error. Are you getting it?
Ma'am, can you
Is
once
it okay?
repeat it?
Okay. I said, let's say you have 10 readings of something. Okay. First, you have to calculate the average, which we will call as true value or the actual value. Now, in order to find out the absolute error, we have to calculate the difference or the deviation from actual value to the reading. So whatever the difference you have in actual value and reading, that would be your absolute error. For an example, in measuring this reading, this first reading, I did this much absolute error, and it is nothing but x mean minus x1. Okay. So this absolute error, is it okay, Shikha?
Yes, ma'am, got it.
Okay. So these absolute errors can be positive, can be 0, or they can be negative also. Okay? Cool?
Yes, ma'am.
Okay. Let's come to mean absolute error. You already know about this absolute error. Just take the mean. Hey, you have delta x1, you have delta x2, and similarly you have delta xn also. And if I want, please calculate the mean, so what would you do? Sum of the given data upon number of the given
Number
data.
of observations.
Yeah. Right? So this is your mean absolute error. Make sure that you remember always that this mean absolute error is positive. Always. Okay? And this is very important because whenever somebody gave you an experiment and you are supposed to give them answer, the result, so you will always represent it in mean absolute error. For example, I give you, let's calculate the length of a wooden block. Okay? So you will answer me the length of this given block. I think you maintain that experimental notebook now, that experiment wala, where you wrote the aim, apparatus required, formula, theory, procedure, observation table, calculation, vagara, vagara. Is it something that you have? Are you actually familiar
Yes,
about
ma'am.
that?
Yes, ma'am.
So in the result, you will answer it something like this. Wait a second, bacha. For example, 5 centimeter plus minus 0.5 centimeter. Just one instance. So this 0.5 now, this is your mean absolute error. And this is a most acceptable way to register any data. To give any data, you need to write it in this form only. X plus minus delta X. I think you use this kind of terms in your daily practices कि ऊपर नीचे 21 20 है ना? We use it 19 20 21 22 something like this कि ज़्यादा फर्क नहीं है. There is nothing much here, कुछ ऐसा difference ज़्यादा नहीं है. In that situation, what does it actually means? कि for example here 5 plus 0.5 and 5 minus 0.5. It means from 5.5 to 4.5. This length is lying within this range. Is that okay?
Yes, ma'am.
Cool. Now let's come to the another error, which is relative error. Relative error is important one. It is known as fractional error also. Okay. So this is your mean absolute error. When you divided it with the true value or mean value, this is your relative error. It is mean absolute error. This is the mean value. Okay, and this entire term is known as relative error. If I take the percentage of that data, then it would be, okay, just wait a minute. Then it would be delta X by X into 100. This is the percentile error. If I ask you to remember two errors, then it would be percentage error and relative error. They are very important. Okay, make sure you remember that. Okay. So can you summarize the entire class? जो भी याद आ रहा है.
Significant figures and rules.
Okay.
Rounding off
Rounding
and
off.
errors.
Nice.
Error.
Anything else?
Error.
Types of error.
Yes. Can you tell me the name of different errors?
Absolute error.
Mean
Mean
absolute error.
error.
Mean
Very
absolute
nice.
error.
Relative error. Percentage error.
Relative error.
Very good. What is the other name of relative error?
Fractional error.
Cool. Okay. So that's it for this class. I will, okay. This rounding off. Please take the screenshot of this part only. This is your homework. Okay. Okay. As I mentioned it earlier also, please make the formula sheet for your own ease. Okay. In next day, we will discuss propagation of error and experimental instruments. See, experimental instrument is something which is deleted from your NEET syllabus unit 1, but it is added in experimental methods, which is the last unit in your syllabus. So, the bottom line is that we need to discuss these topics. In experimental instruments, we will discuss about vernier caliper and screw gauge. Make sure that you are familiar with this instrument, with few things about it, basic terminology, okay? So that I can continue my class with numericals. Okay? Cool? This is your pre-work. Okay. So thank you so much. I'll see you in the next class. Till then, be happy. And after that also. Bye-bye. Okay, see, I guess you have a form over here. Please fill it, kindly copy it down so that I can cut the class. Please do it.